Today we're talking about the union and intersection. Very quickly, very easily, I'm going to talk about this using these two Venn diagrams here. The union of two sets is basically all of A and all of B shaded together. So you can think about it this way. Anything in A or anything in B is inside the union of A and B. Okay? The word associated with the union is the keyword or. So, for example, if I were to say, actually, I'm going to write it on above here, or. If I were to say, during the Easter break, I will be in Rio de Janeiro or in Fernando de Noronha. In that case, I would take a map and I would color all of Rio de Janeiro and I will also color all of Fernando de Noronha. Okay? Or if I were to say, I will be eating this or I will be eating that, then you don't really know. It's either this or that. So you have to shade everything there because you don't know. It could be this, it could be that. So this is the idea with the union. But now the intersection of two sets means that they are happening together at the same time. So we're really talking about the common elements in there. Okay, so let me think of a real life example now. If I say that during the Easter break, I will be learning how to speak Portuguese and Spanish, then it means absolutely I'll be doing both. Okay, I'll certainly be doing both. So the intersection is associated with the keyword and. So when we have worded problems, keep this in mind. Anything that's got to do with and is associated with the intersection. Anything associated with or is the whole thing shaded in. So let's move on to some practical problems here. So if they say, let's go ahead and put these this data into the Venn diagram, how would you create this Venn diagram? Well, you're given A is 2, 3, 4, 7. You're given B is 1, 3, 7, 8, 10. What are the common elements? 3 and 7. Thank you, guys. 3 and 7 indeed. So these two numbers go ahead and, well, we go ahead and put them into the intersection. So these two elements, 3 and 7, go in here. And notice we only put them once. Okay, we don't need to put them twice because it goes without saying that they count for the circle of A and they also count for the circle of B. And another way of writing that down, this intersection has this notation, which I didn't stress previously. It's got this notation, which is the upside down U. So let me go back here and emphasize this. The intersection here has this upside down U as the symbol. Okay, so symbol for the intersection. And for the union is the big letter U. So this is the symbol for the union. It's actually bigger than a U. It's a symbol, but it's obviously taken from that first letter of the word union. So coming back to this, the intersection is 3 and 7, and the union is basically everything together, everything included. So notice 1, 2, 3, 4, 7, 8, and 10. And notice I don't list anything twice. I just have 1, 2, 3, 4, 7, 8, and 10. Okay, and I'll just put it all in there. Now, that is pretty much it. Oh, by the way, if there's anything which is not in A or not in B, we'll have to just put it outside. Just keep that in mind. Disjoint sets. Two sets, A and B, are disjoint if they have no elements in common. Or in other words, A intersection B is this this symbol here. We've seen this before, guys, haven't we? This is the empty set, the set which contains nothing. So it's like, imagine an empty box, that sort of thing. So the intersection between A and B is the empty set. So let's just remember that this symbol here means the intersection. So basically, what are we saying in terms of a Venn diagram? If I were to sketch this, it would mean that if I were to put the set A in here and set B in here, they would have absolutely no common elements. So you can imagine they sit far away from each other. They've got nothing in common. Okay, disjoint. But if they are non-disjoint, they will actually have an intersection, so they will cross each other like this, A and B. So here, this would be non-disjoint, which is a double negative in a way, but anyway, don't worry about it. Non-disjoint. Yes. Don't try to make sense of the English language, please. It's a crazy language. Okay, good question though. Yes, good question. Non-disjoint. If it were a logical, a mathematical language, more logical language, then it would be joint. Yes. But then on the other hand, think about it this way. In Portuguese, you say eu não tenho nenhuma ideia. But in English, you say I have no idea, which is more logical. If you say eu não tenho nenhuma ideia, it's like you're saying you've got an idea because it's a double negative. So in every language, we've got these paradoxes where the brain doesn't make sense of things. But in maths, this doesn't happen. Maths makes sense always. It's a logical thing. We love maths. Okay, so if u is all the positive integers which are less than or equal to 12, so what would that be? Positive integers less than or equal to 12? Get ready. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so positive integers are integers, whole numbers which start from 1 and end with 12. And then if we have primes which are less than or equal to 12, well, what are those? 2, 3, 5, 7, 11. So generally, we want to remember the primes by heart. We want to be able to work them out. Factors of 12. Well, remember factors, find factors of a number. You have the ways to write it down as a product. So 12 is 1 times 12, 2 times 6, 3 times 4. So all the factors of 12 are 1, 2, 3, 4, 6, and 12. So now that we've got all of this information, they say, put this stuff into the Venn diagram. So, you know, we've got A here, we've got B here, we've got U, which is between 1 and 12. And now we start putting this stuff in. We always start from the intersection. So what are the common elements here? 2 and 3. Yes, let's go ahead and put that stuff into the intersection. And then we put the leftovers in there. I've taken the 2 and the 3 out from the A. So what am I left with? 5, 7, 11. I put 5, 7, and 11 in there. Done. B, I've taken the 2 and the 3. Great. So let's put in the rest in there. 1, 4, 6, and 12. 1, 4, 6, and 12. Done. And now that I've put all of that stuff in, I have to remember to put in the leftovers outside the circles. So which numbers between 1 and 12 have I not taken already? So I do 1, 2, 3, 4, 5, 6, 7. But notice 8 is not in the circle. So I put an 8 out there. Then I check, do I have 9? Not yet, so I put a 9 out there, anywhere outside the circle. Then I try to find 10. 10, where is 10? Nowhere, so I put a 10 in there, outside the circles. And then I've got 11 and 12 in there, so we are done. We've finished with all the numbers in U, so that's how you complete the Venn diagram. So do keep this in mind. It's a classic question. Complete the Venn diagram should be a really happy thing for you. That's why I'm putting a smiley face here. You should get 100% always. A dash. This is, remember, the complement of A, things outside A. So what is not included in A? All you have to do is look at the Venn diagram. Ah, classic mistake. Remember, so anything outside A is anything outside this red circle. So we don't really care if it's inside another circle. Yes, so it is 1, 4, 6, 12, 8, 9, 10. All of these numbers are outside the circle of A. It's like saying, who is not in this classroom? Well, everyone in any other classroom in the school. You wouldn't say, oh, they're in another classroom, so I'm not going to mention them because they're in another classroom. Same idea here, because these numbers are in another circle, in another Venn, in the set B. It doesn't really affect us in any way. We can still say these are outside A, and they're in A dash. Moving on to what is the intersection? Well, easily done here. We can say that the intersection of A and B is 2 and 3. What is the union of A and B? Everything in A and everything in B, but make sure you list them once. So
2 and 3,
5, 6, 7, 11, and 12. Sorry, for the previous question, yes, you were right. 2 and 3 is in the intersection. Let me just once again mention these words. Intersection.
when it's the union and when it's the intersection, like I don't understand.
Imagine, think about it this way. Union, I take one thing, and I take another thing, and I put them together. Union, I united them. Yes? Intersection is you take one thing and you take another, and when they cut each other, intersect, sect from, I think it's Latin for cut. That's the intersection. So let's keep that in mind. Let's move on to the N. That N keeps coming up all the time. Number of the intersection, number of A intersection B. In this case, is how many things you have in the intersection. It's 2 and 3, so it's 2 things. So we say the number of elements in A intersection B. So remember that number of, this is the N of something. Number of, this is N of something. Okay, keep this in mind. It will come up all the time. It will come back to haunt you, always. Moving on to this one. The number of elements in the union. So the union of A and B is 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Yes, I counted correctly this time. Yes. So here, this is the number of elements in the union. So we just say it's 9. So the union is all of this. So the 2 circles all together. Moving on to B dash. B dash, once again, to tell us what is in the B dash, what is not in the circle of B. 5, 7, 11, 8, 9, 10. Nicely done. This time, no mistake. Excellent. Quick turnaround there. Okay, great stuff. So B dash means outside the circle of B. So we include those things which are in another circle. We don't really care if they're in another circle or not. All we were asked is, are they outside B? Yes, they are. So 5, 7, 11, 8, 9, 10. Boom. Okay, and now n of B dash, and I think I'm going to end with this one. The number of elements in the complement of B. So outside B. That would be 1, 2, 3, 4, 5, 6. So 6 numbers. And that's pretty much it. Have a go, guys, and I'll be right here to help you with any questions, any problems you might face. So let me just stop the recording and start helping you.